Morning all. Am I audible? Say yes or no in the chat. Anybody can chat. Ishbu, am I audible? Say yes or no. Loud and clear. Ishbu, am I audible? Say yes or no in the chat. Am I audible, guys? Say yes or no. Okay, loud and clear. Is my presentation is visible to you? Okay, thank you for informing. So I'm just going to start this lecture. Today we are going to discuss about the unit number 8. The name is array-based implementation of graph, agency matrix, linked list representation of graph, and shortest path algorithm, right? So these are the topic. Basically, we are going to discuss about the topic. The name of the topic is graph. And we'll discuss about the various algorithm, implementation, and various terminologies related to the graph. So these are the objective. By the end of this session, learner will be able to understand about the array-based implementation of graph, agency matrix, path matrix, linked list representation of graph, shortest path algorithm, graph traversal, BFS, that means breadth first search. So these are the topic that we are going to cover today. So first we start with the definition of the graph, then we'll understand the different component like complete graph, agency matrix, incident, subgraph, path, cycle, a cyclic graph, degree of vertex, graph representation. Finally, we will discuss about the few graph traversal algorithm. So without wasting a time, we are going to start about the definition of this graph. So what is the graph? And a mathematically, graph can be defined as a graph G consists of two sets, right? The first one is the, I'm typing over here, just understand. One set is called VG, another set is called EG. EG is the set of edges, VG is a set of vertices that is inside the graph. So the mathematically graph can be represented as a set of V and G. So it is called GVE, represents a graph, right? So there are two sets. First one is the set of edges. Second one is the set of vertices. And with the help of these two sets, we can represent a graph mathematically in the form of G, V, E. So now what do you mean by undirected graph? So an undirected graph is one in which pair of vertices in a edge is unordered. Unordered means there is no order, means a edge between V0 to V1 is similar to an edge between V1 to V0. For example, this is vertex V0, this is vertex V1. These are the two vertices, and if they are connected, so we cannot identify the direction of it. So it is called undirected graph, right? Edge is unordered. There is no edge. There is no arrow in the edge. That means the edge between V0 to V1 is equivalent to V1 to V0. A directed graph is one in which each edge is a directed pair of vertices like V0 to V1 that is not equal to V1 to V0. For example, there is a node V0, another node is V1, or you can say vertex. So if there is a connected edge between V0 to V1, it doesn't mean there is exist an edge between V1 to V0, right? So this kind of graph is called directed graph, in which an edge between V0 to V1 is not equal to an edge between V1 to V0. For example, there is another edge. It is having direction between V1 to V0, right? And this is the edge to have direction from V0 to V1. So these are the two different edges. These are the two different edges. There is not a single edge, right? So that type of graph in which edge have some direction from one node to another, that is called directed graph. So this graph is undirected graph. This graph is directed graph. I hope it is clear in your mind. So just move to the next slide. Now try to understand about the different examples of the graph. So here, this is graph G1. There is another graph that is called G2, right? So G1 can be called as a complete graph because there is a direction, there is a connected edge between every node to another node. That means every node V0 have an edge to V1, right? Vi to Vj, for example. Here, 0 is connected with 1, 2, as well as 3. Similarly, 1 is connected to 0, 2, and 3. Similarly, 2 is connected to 0, 1, and 3. Similarly, 3 is connected to 1, 0, and 2. With the another node is called the complete graph. Incomplete graphs like G2 and G3 are called the incomplete graph because there are some edges between a node to another node, but there is not a direct edge between the one node to another node. For example, from 0 to 3, there is no direct edge. From 6 to 0, there is no direct edge. 5 and 6, there is no direct edge. Between 3 and 4, there is no direct edge, but they are connected. So we can say this is a graph, but it is called incomplete graph. Similarly, in Z3, there is an edge between 0 to 1 as well as from 1 to 0, but this node 2 doesn't have direct edge between 0 to 2. It is connected, but it is not directly connected. There is no direct edge between node 0 to node 1, 2, sorry, right? So these graph can be called as a incomplete graph. Now, the very, very important thing that can be asked in a multiple choice question, in a complete undirected graph, n into n minus 1 divided by 2 are edges are available. Means number of edges. If a complete graph will be given to you and the number of edges will be asked, so with the help of this formula, n into n minus 1 and divide by 2 is the total number of edges. Just try to understand with the help of this example. See, this is a complete graph, and in this complete graph, total number of edges are n into n minus 1 divided by 2. Someone is saying something. Let me check. Okay. All are typing their roll numbers. Okay, just have a look towards. So where n is the number of nodes, with the help of number of nodes, we can calculate the number of edges. 1, 2, 3, 4. There are 4 nodes are available over there. So total number of edges in undirected. This is undirected because there is no direct edge. There is no direction available over to the edge. Direction is not mentioned over to the edge. So 4 into 3 divided by 2. So you can say 12 divided by 2. You can say total 6 edges are there. Now just count 1, 2, 3, 4, 5, and 6. Total 6 edges. So we can calculate the number of edges with the help of this formula when we know the number of nodes in a complete graph. Remember, in a complete graph, right? Now, if a complete directed graph, total number of edges will have n into n minus 1. So what do you mean by complete directed graph? Means the edges having some direction mentioned over to it, right? Now, for example, just try to understand. Just try to understand with the help of example. I'm just going to mention an example over here. Say there is a graph, node 1, node 2, and node 3. Right. So now here you can say node having multiple edges, because this is a directed graph. So we can move from 1 to 2, as well as we can move the direction from 2 to 1. Similarly, we can move the direction from 2 to 3 and 3 to 2. Similarly, we can move towards the from 1 to 3 and 3 to 1. So two edges are over there, two edges are over there, two edges are over there. Total number of nodes are 3, total number of edges are 6, right? Two edges, two edges, and two edges. Total number of edges are 6. So with the help of this formula, we can also calculate the same number, because we are having total 3 nodes. So 3 into 2 is equal to 6. So in a directed connected graph, if we are having n nodes, so total number of edges will be n into n minus 1. So remember, in complete directed graph, number of edges will be higher than the complete undirected graph. As you can say, double of the complete undirected graph, right? So just move to the next slide, complete graph. So what is complete graph? When complete graph is graph that has the maximum number of edges, that has the maximum number of edges, that is called complete graph. And we have seen in the previous slide. So in this case, you can say this graph G1 is a complete graph, because this graph having maximum number of edges. Every node is connected to the another node directly. Every node is connected to the another node directly, right? Now, what do you mean by adjacent and incident? Try to understand the terminology of the graph. What do you mean by adjacent and incident? For example, if V0 and V1 is an edge in an undirected graph, V0, V1, there is an edge between V0 to V1, and there is no direction, so undirected graph, then we can say V0 and V1 are adjacent node. So here you can say V0 and V1 are two adjacent node. These are the adjacent node. V1 and V0 are the adjacent node. Now, what do you mean by incident? V0 and V1 is incident on vertex V0 and V1. That means you can say V0 and V1 are, this edge is called incident. The edge between V0 and V1 is called incident. Incident on vertex V0 and V1, right? Now try to understand another in a directed graph. So V0 and V1 is an edge in directed graph. Now we are going to make it directed graph, say V0, V1, and I'm going to draw a line between V0 to V1. Now there is a direction of this arrow, right? So if V0 and V1 is an edge, so this is an edge in directed graph. So V0 is adjacent to V1. So V0 is adjacent to V1. V0 is adjacent to V1. This is called adjacent node. And V1 is adjacent from V0. Now just remember, adjacent to V1, adjacent from V0. This is word is from, there is word is to. What it means? It's showing the direction of an edge. Showing the direction of an edge. That means the direction of an edge is from V0 to V1. It says V0 is adjacent to V1. Means direction of edges V0 is adjacent to V1. And here V1 is adjacent from V0. That means edge is coming from V0. Edge is coming from V0. So that is a difference between the directed graph and undirected graph. In undirected graph, we can say vertex V0 and V1 are adjacent, but in a directed graph, it depends on the direction of edge. On the basis of that, we can write the statement V0 is adjacent to V1 means the direction is from V0 to V1, and adjacent from V1 is adjacent from V0 means the edge is coming from V0 to V1. So the edge V0, V1 is incident on V0 and V1. So this is the incident, the edge is incident. Right? The two adjacent from, it signifies the direction of the edge. Now the next slide is the next topic, basically the graph with feedback loop and a multi-graph. Now, what do you mean by loop? What do you mean by feedback loop? And what do you mean by multi-graph? We can understand with the help of examples. In this graph A, you can see 0 is connected with 2 and 2 is connected to 0. So it's making a loop. Making a loop. Similarly, from 1 to 0 and 0 to 2 and 2 to 1, it is also making a loop. Right? So if in a graph, if there is a loop, so we can say loop. What do you mean by self loop? Here you can say the edge which comes from 0 and again it's going towards the 0. There is an edge. It's come from node number 1 and it's again going to the 1. So such type of edges are called self edge. That type of edge is called self edge. So I hope so. It is clear in your mind what do you mean by self edge, what do you mean by loop, right? Now have a look towards the graph number B. In this graph, you can see there are multiple edges from 1 to 3 and from 1 to 3, right? This is edge from 1 to 3. There is another edge from 1 to 3. Similarly, there are multiple edges between 2 and 3, right? So if a graph, if there is an undirected graph and a two node having multiple edges among each other, so such type of graph is called multi-graph. Multiple occurrence of the same edge. If multiple occurrence of same age is available in a graph, so that type of graph will be called multi-graph. I hope so. It is clear in your mind. So what do you mean by multi-graph? So if is there any issue, if is there any problem, if my voice is not clear, if my PPT is not clear, or you are not able to understand, please ask me. I'll repeat it again, right? I'm here to solve your problems. I'm here to make it understand to you. Now I'm just going to move towards the another topic that is called subgraph and path. So what do you mean by subgraph? What do you mean by path? Just we'll try to understand. Path and subgraph. A subgraph G is a subgraph of G is a graph G dash. A subgraph of G is a graph G dash such that B of G dash is a subset of VG and E of G dash is a subset of EG. That means if there is a set of vertices and there is a set of edges, so if we are making another graph by taking few vertex and few edges from these two sets, and we are making a graph using that, so that kind of graph will be called subgraph of original graph G. Right? I'll explain with the help of few examples what do you mean by graph and what do you mean by subgraph. Right? But mathematically, try to understand a subgraph of G is a graph G dash such that V of G dash means few vertex from G dash from G2 inserted into G dash, and EG dash means the set of edges are taken from E of G means set of edges of graph G. So a path from vertex VP from vertex VQ, we are trying to understand path. So path from vertex VP to VQ in a graph G is a sequence of vertices like VP2, VI1, from VI1 to VI2, and from VI to VIN, and finally we are reaching to VQ. So if we are reaching from VP to VQ and there are multiple vertices are in between the path, so all these vertices will be considered as a path between VP to VQ. So such that edges are over there. There is an edge between VP to VI1, VI1 to VI2, VI2 to VIN, and VIN to VQ. So these all edges in undirected graph will be considered as a path between VP to VQ. What is the length? The total number of edges in the path is called the length. The total number of edges in the path is called the length. Now try to understand with the help of example. This is a graph G, right? And a part of this graph is this 0. So this is a subgraph 0, 1, 2. This is also a subgraph of G 1, 2, 3. This is also a subgraph of G because it is a part. This part of graph is available into the G1. This is also a subgraph of G1 because this type of graph is available into here G1. So 1, 2, 3, and 4 all are the subgraph of graph G1. All are the subgraph of graph G1, right? Because 0 itself available into G1. This path 1 and 2, this is also available here. So you can say 0, 1, 2, 1, 2, 3. So you can say 1, 3, 2. This is also available here. 0, 2, 3, 1. So it is also available like 0, 2, 3, from 3 to 2, and from 2 to 1. It is also available here, right? So these all four are the subgraph of graph G1, right? Similarly, in directed graph. So this graph is a directed graph. So in this directed graph, this 0 is also a subgraph of this. 0 to 1, it is also a subgraph. 0, 1, 2, it is also a subgraph. 0 to 1 and 1 to 0, it is also a subgraph. And only 2 is also a subgraph. Right? So these all are the subgraphs. All are the example of subgraph. Few examples are from undirected graph. Few examples are from directed graph. Now, what do you mean by path? Try to understand the path also. For example, if we want to, I hope the presentation, the slide is visible to you. Say yes or no. Everybody, anyone can chat. Is my presentation is visible to you? Say yes or no in chat. Okay, very good. So what do you mean by path? Try to understand path. I want to start from 0 and want to reach to 6, right? So if I am going to start from 0 and want to reach to the 6, so I have to travel a path like 0 to 2 and 2 to 6, right? So the number of edges between this path are total path. So path between 0 to 6 is 0 to 2 and 2 to 6. 0 to 6, this is the path. 0 to 6, this is the path. So by this path, I can reach from 0 to 6. I can start from 0, I can reach to 6, right? So similarly, if I'm going to start from a particular node, I want to reach to a particular node. In between, how many edges are over there are called the path. Now try to understand simple path and cycle. What do you mean by simple path and cycle? A simple path is a path in which all vertices except possibly first and the last node. First and last node. Except first and last node. So a simple path is a path in which all vertices except possibly the first and the last are distinct, are called the simple path. Means first and last are not the same node, right? Means 0 to 1, 1 to 3. This is 1, this is 2, this is 3, and 1 to 2 and 2 to 3. So first and last are distinct. So this is called simple path. This is called simple path. 1, 2, 3, 1, 2, 2, 2, 2, 3. So you can write like that 1, 2 and 2, 3. So this is the path through which I can reach from 1 to 3. So starting node and ending node are distinct. Starting node and ending node are distinct. So this kind of path is called simple path. So what do you mean by cycle path? Just try to understand. A cycle is a simple path. Cycle is a simple path in which the first and the last vertices are same. For example, 1 to 2, 2 to 3, and 3 to 1. So the first node and the last node are same. The first node and the last node are same. So that type of path is called a cycle path. A cycle. That is called a cycle, where the first and the last is same. So in an undirected graph G, two vertices V0 and V1 are connected if there is a path in G from V0 to V1. So these nodes are called connected node if there exists a path between these two nodes V0 and V1. So that we can say these are connected nodes. An undirected graph is a connected if for every pair of distinct vertices Vi and Vj, there is a path from Vi to Vj. Right? So in an undirected graph is connected if for every pair of distinct vertices Vi, Vj, there exists a path from Vi to Vj. There must be a path from any node to any node. So that type of graph is called connected graph. That type of graph is called connected graph. Means we can start from any node and we can reach to any other node. If there is a path between these two nodes, so the complete graph is called connected graph. Just try to understand connected, cyclic, and acyclic graph. This graph G1 is called connected graph because there exists a path from any node to any node. For example, I want to reach from 0 to 3. So 0 to 3, there is a path, right? I want to reach from 0 to 1. So there exists a path to reach from 0 to 1, even though there exists a path here, so that I can start from 0, 0 to 2, 2 to 3, 3 to 1. So there exists a path from which I can reach from any node to any node. In this graph, this is called cyclic. This is called cyclic because there are multiple paths, and there we can say to the another node. So that kind of graph is called cyclic. So this is called cyclic. This is cyclic. And this graph is called connected but a cyclic graph. So there is a path from 0 to 6. There is a path from 0 to 5. You can say like that, right? There is a path from 0 to 4 like that. There is a path from 4 to 0. There is a path from 0 to 1 and 1 to 3, right? So, but there is no cycle. No cycle. There is no loop. There is no loop. So if a graph having no loop, so it's called a cyclic graph. A cyclic. This is a graph, but there is no loop. Loops are not available. Right? So this is acyclic because there is no loop. This is cyclic because there is a loop. You can say 0, 3, 1 and 1 to 0. 2 to 3, 3 to 1 and 1 to 2. We can find a cycle, right? Therefore, it is called a cyclic graph. I'm just going to move towards the another topic. Connected components. What do you mean by connected component? I told you subgraphs, right? So subgraphs are the connected components. Say there is a graph, so H1 and H2 are connected, right? Not directly. There is no direct connection between H2 and H1. So we can say these are the not connected graph, right? These are the not connected graph. A graph with two connected component. A graph with a two connected component, but they are independently not connected. This H2, 4, 5, 6, 7, anyhow, this is connected with each other. H1 is connected with each other. but H1 and H2 are not connected with each other, right? Strongly connected component of G3. So this is a G3 and this is a strongly connected component of G3. Because why it is called strongly connected? One is connected to 0. There is a direct edge between 0 to 1 and another edge from 0 to 1, from 1 to 0. So it's called strongly connected subgraph, or you can say strongly connected component of G3. So this is G3 and this is strongly connected. Another topic is called degree. What do you mean by degree of a graph? So degree is of vertex. We can calculate the degree of any vertex. So degree of the vertex is a number of edges incident to that vertex. Remember, edges incident to that vertex. That means it is coming from somewhere else, some another node. The edge is coming from another node. Therefore, we are saying incident to any vertex. For directed graph, there are two different types of degrees. First one is called in degree and second one is called out degree. This is case only in directed graph. This is the case only in the directed graph, whereas in undirected graph, there is only degree, there is no in degree or no out degree, right? What do you mean by in degree? What do you mean by degree? What do you mean by out degree? We'll understand with the help of example. So the in degree of a vertex V is the number of edges that have V as head. V as head, that is called in degree. For example, this is a node V. Edge is coming towards the V. This is the arrow. This is the direction of the edge, right? So this arrow is called in degree. In degree. For example, there is an edge V. This arrow direction is like that. So this arrow direction will be counted as a out degree. It is counted as out degree because the direction of array is going from V to another node. So this is in degree, direction is like that. This is out degree, direction is from V to another. This is called out. So the degree di is the degree of a vertex I in graph G with n vertices and e edges. The number of edges is, you can calculate with the help of formula. The degree can be calculated with the help of this formula. What is the formula? Just have a look. Number of edges is equal to, if degree is given, we put the number of edges. Degree of edges E is equal to summation from 0 to n minus 1, where di divided by 2. So with the help of this formula, we can calculate the total number of edges. If in degree, so degree in undirected graph, here graph G1, here graph G1 is undirected graph. There is no direction mentioned over to the edge connection, right? You can say degree of vertex 0 is 3. Why 3? Because 0 having 3 edges from 0 to 3, 0 to 2, 0 to 1. 3 edges are over there. So degree of vertex 0 is 3. Similarly, degree of vertex 3 is also 3 because it's connected from 3 to 2, 3 to 0 and 3 to 1. So degree of node 3 is also 3. Similarly, degree of node 2 is also 3 because it is connected with 0, it is connected with 3, it is connected with 1. There is an edge from 2 to 0, 2 to 1 and 2 to 3. So therefore, the degree of node 2 is also 3. Degree of node 3 is also 3. Similarly, the degree of node 1 is also 3 and degree of node 0 is also 3. In this graph, the degree of node 0 is 2 because it is connected with two vertices directly. Similarly, the degree of node 2 is also 3. Why 3? Because 2 is connected to 6. 2 is having age between 2 and 5. There is an age between 2 and 0. So 3 edges, 1, 2 and 3. So 2 is connected with 3 edges. So degree of 2 is 3. Similarly, the degree of 6 is 1, degree of 5 is 1, degree of 4 is 1, degree of 3 is 1, but degree of 1 is 3 because it is connected with 3 different edges. It is connected with 1 to 0, it is connected with 1 to 4, it is connected with 1 to 3. It is connected with 3 nodes. Therefore, the degree is 3 of node 1. Degree is 3 of node 2. Degree of node 6 is 1. Degree of node 5 is 1. Degree of node 4 is 1. Degree of node 3 is 1. Degree of 0 is 2. I hope so. It is very much clear in your mind how to calculate the degree of a graph. Now, in case of directed graph, here you can see the graph G3 is a directed graph because there is a direction on the edges. There is a direction on the edges, therefore it is called directed graph. So in the directed graph, we know that there are two different types of degrees. The first one is called in degree, the second one is called the out degree. So in case of node number 0, in degree is 1 because one arrow is coming towards 0. So in degree is 1. Similarly, the out degree of 0 is also 1 because one edge going from 0 to another node, that is 1, right? This. So this is out degree. One edge is coming, in degree is 1. One is edge is going towards another node, is therefore out degree is also 1. Similarly, in degree and out degree of node. So node 1 having one out degree, another one out degree because two edges are going outside the one. So 1 and 1, these are the out degree. So total out degree are 2 and only one edge is coming from 0. Here you can say in degree is 1. In means coming to inside the node, that is called in degree. Out means the edges are going outside the node, called out. Right? Similarly, the in degree of node 2 is 1 and the out degree is 0. No another edge is going from 2 to any other node. Right? So that is the meaning of degree, in degree and out degree. In degree, out degree in case of directed graph, whereas in case of indirected graph, only degree will be considered. Now, how graph can be represented into the memory? So graph can into the memory. Am I audible? Say yes or no in chat, loud and clear. Anyone? Give me the answer into the chat. Am I audible? Loud and clear? Very good. Okay. Graph representation. The graph can be represented into the memory using two different manner. The first one is using the adjacency matrix. And second one is the adjacency list. matrix can be implemented using 2D array, and list can be implemented using linked list, right? And array linked list we have already learned in the previous chapters. So it's the array representation of graph, and this is the linked list representation of graph. So array based implementation of graph, that is matrix. Let's G is a graph consisting vertex and edges, be a graph with vertices n, total number of vertices are n in this graph. So the adjacency matrix of G is a two-dimensional n by n array that is called adjacency matrix. If the edges is in the set EG, so adjacency matrix size will be mat ij is equal to 1. That means if there is a connection, if there is an edge between Vi to Vj, so in that matrix, the value will be 1 in that case. If there is an edge between Ij, so value in matrix will be 1. If there is no such edge in Vi and Bj, so value at that location in the matrix will be 0. So 1 means there is an edge between two nodes. 0 means there is no direct edge between these two nodes. Adjacency matrix for undirected graph is symmetric. The adjacency matrix for a digraph need to be symmetric, right? So this graph G1 is undirected graph. You can see there is no direction mentioned among the edges that are between the vertices. Like there is a edge between 0 to 2, but direction is not mentioned. So this graph is called undirected graph. Now, how this undirected graph can be represented into the memory? So into the memory, it can be represented with a C matrix. So how the value, what are the value, how the value can be stored into the adjacency matrix, try to understand. Total number of nodes 4. So we have to create a matrix of 4 cross 4, where total number of rows are 4, total number of columns are also 4. So we need to take a symmetry matrix of 4 cross 4, right? 0, 1, 2, 3, 0, 1, 2, 3. So these are the symbolic representation of nodes, nomenclature of vertices, right? Is there any edge between 0 to 0? No, there is no edge between 0 to 0. So we are writing 0 here. Is there any edge between 0 to 1? Yes, between 0 to 1, there is an edge. So we put 1. Is there any edge between 0 to 2? Yes. So between 0 to 2, there is edge. So we are writing 1 here. Is there any edge, direct edge between 0 to 3? Yes. So we are writing 1. So if there is a direct edge between any node to another node, so we can write 1 over here. So we are taking this 0, 0 to 0, 0, 0 to 1, 1, 0 to 2, 1, 0 to 3, 1. Because there is an edge between 0 to 1, therefore we are mentioning 1. There is an edge between 0 to 2, therefore we are writing 1. There is an edge, therefore we are writing 1 in that case. Similarly, from node 1 to another node. So 1 to 0. Yes, 1 to 0, there is an edge. So we are writing 1. 1 to 1, no edge. So we are writing 0. 1 to 2, yes, there is an edge. So writing 1. 1 to 3, yes, there is an edge. We are writing 1. Similarly, from node 2, 2 to 0, there is an edge. Yes, we are writing 1. 2 to 1, there is an edge. Yes, we are writing 1. 2 to 2, there is no direct edge. So we are writing 0. So 2 to 3, yes, there is an edge, so we are writing 1 here. Similarly for 3, so 3 is connected to 0, yes, writing 1. 3 is connected to 1, yes, we are writing 1. 3 is connected to 2, yes, writing 1. 3 is connected to 3, so there is no edge, so we are writing 0. So this is the way by which we can store the values in a adjacency matrix. So our computer can read these values, and with the help of these values, it can draw a graph. If there is 1, it will draw a line. If there is 0, it will not draw a line between the nodes. Right? So in this way, we can store a graph into the memory in the form of adjacency matrix. So values of adjacency matrix will tell us, is there any direct edge between the two vertices or right? Similarly, for graph G2, this is a adjacency matrix. There is no direct edge between 0 to 2, so you can say 0, 1, 2. So 0 to 2, 0, 1, 2. So 0 to 2, there is no edge, so 0 is mentioned. Similarly, 2 to 0, there is no edge, so it is 0. 0 to 1 and 1 to 0, there are direct edges. So 0 to 1, 1 is mentioned, and 1 to 0, so 1 is mentioned. I hope so. It is clear in your mind how a graph can be represented in the form of adjacency matrix. Another example of graph G4, this is unconnected graph. There is a graph, but these are the unconnected graph. Joined graph, because this part of graph is not joined with the another part of graph. So completely it is a graph, but it is a unconnected disjoint graph. So it can also be represented in a adjacency matrix because there are total 8 nodes are over there. So 8 cross 8 matrix we have created. So 0 means there is no direct edge. 1 means there is a direct edge between the nodes. Right? So what are the merits of adjacency matrix? From the adjacency matrix to determine the connections of vertices is very easy. This is the merit. The degree of vertex can be calculated with the help of this formula, where summation of j is equal to j to n minus 1, where n is total number in the matrix or in the graph, and we can find out the sum of all ones, that is the edges available between the vertex vi to vj. So sum of all vertex available, the edges available between vi to vj will be the degree of that particular node. For a diagraph, the rows sum is out degree while the column sum is the in degree. Diagraph means there is bidirectional, you can say arrow is available, directional arrow is available from 0 to 1 and 1 to 0. So that is called diagraph. So for a diagraph, the row sum is the out degree while the column sum is the in degree. Right? Yeah. Sorry for the inconvenience. Am I audible now? Say yes or no in the chat. Am I audible, guys? Say yes or no. Very good. Thank you so much for the reply. Another, for a diagram means directional, whereas direction from 0 to 1 and 1 to 0, the arrow having direction, right? In that case, in degree and out degree can be calculated. So this formula can be utilized to calculate the in degree, and that formula can be used to find out the out degree, right? So in case of out degree, the sum of rows will be taken. In case of in degree, the sum of column will be taken. So here you can say j is equal to 0 to n minus 1, and here you can say j is equal to n minus 1. It is ji is mentioned here, ij is mentioned here, right? That is the difference between these two formula. Only rest is the same to calculate in degree and out degree. In that case, I told you I represent the row, j represent the column in that case. Only these two are reversed. Here is ji and here ij is mentioned. The rest is same. Now another one is the linked list representation of graph. So like we can represent a graph with the help of 2D array, or you can say matrix. Similarly, the graph can be represented into the memory with the help of linked list data structure. Just have a look. So this graph these are the head of the linked list, head node of the linked list. So if there are 4 nodes in this graph, so 4 linked lists have been created. One linked list for every node have been created over there. So edges, so 0 is connected with 1, so 1 is connected to 2, 2 is connected with the 3, and 0 is connected with the 1. Similarly, for another node, the node number 1, another linked list is there. So 1 is connected to 0, 0 is connected with 2, 2 is connected with the 3. For another node, similarly, 2 is connected with 0, 0 is connected with the 1, 1 is connected with the 3, right? So this addresses this linked the node saying there is a connection between 0 to 1 and 1 to 2 and 2 to 3, right? Just have a look towards the another linked list representation of another graph, the graph mentioned below, the G3. See, this is the graph. Here, 3 nodes are available, 0, 1, and 2. So 3 linked lists have been created, 0, 1, and 2. Right? So first linked list, 0 is connected with the 1. Yes, 0 is connected with the 1. The direction. Similarly, 1 is connected to 0. Yes, 1 is connected to 0. 1, 0 is connected to 2. Yes, 0 to 2. And another 2. There is no out degree in 2. So in that case, there is no direct connection of 2 with another node. Right? Let's try to understand. The out degree of node 1 was 2. So 2 nodes are over there with the node 1. The out degree of 0 was only 1. So in this linked list, 0 and 2 nodes are available. So length of the linked list is depending the out degree of that particular node. So length of node 1 is here, you can say 2, 0, 1 to 0 and 0 to 2. There is 0 out degree of 2. There is no another connected node in that case, right? So that's another method by which a linked list can be created to store a graph into the memory. So I hope so it is clear in your mind how to represent a graph through adjacency matrix and through adjacency list. Adjacency list because it is showing the connection between the nodes. There is another way to store a graph into memory via linked list. This is the graph. This is adjacency matrix representation of graph. This is adjacency list representation of graph. Adjacency list. Some graph operation, graph can be traversal. So graph traversal algorithms are very two important algorithms are available, DFS and BFS. DFS tends to depth first search, BFS tends to breadth first search. And another operation is spanning tree. We can make spanning tree using graph. So in the coming lecture, we'll explain in deeply. We'll learn the traversal algorithm like DFS. We'll learn the traversal algorithm like BFS, right? In detail. So in this session, we have discussed about the array-based implementation of graph, adjacency matrix, path matrix, implementation, linked list representation, and graph traversal like DFS and BFS. I'll explain the DFS and BFS in the next lecture in detail, right? So today only we have learned about the name of these two traversal algorithm, DFS and BFS. Thank you so much. The time is over, so I'm just going to leave from this lecture. I'm going to come out from this lecture. Thank you guys. Thank you so much for listening me patiently.